Yes, last class. Yes, all this introduction discussed, course introduction, Java introduction discussed. Next, yes, introduction to software. Yes, also discussed system software, application software. Okay, next about ways. Yes, next about ways. Okay, these are next front ends, back end software, language and packages, low level language, high level languages, and all these basics completed. Generation of computers. Yes, low level, high level languages completed. Next, yes, today we should discuss about interpreter and compiler. Interpreter and compiler. Today we should discuss about interpreter and compiler. So what's the difference between interpreter and compiler? See, today topic is about interpreter and compiler. Yes. Yes, interpreter, and compilers. Interpreter and compilers are easy to convert from interpreter and compiler. Interpreter and compilers are easy to convert from high level language, to binary codes. High level language to binary codes. Yes, interpreter and compilers. Interpreters and compilers are used to convert from high level language to binary codes. Interpreter and compilers are used to convert from high level language to binary codes. Okay. Yes. What is interpreter? What is compiler? Let us see about this. Interpreter and compiler. Yes. Yes, both are to convert from high level language to binary codes. Both are to convert from high level language to binary codes. But some difference is there. What's the difference here? Yes, let us see. Both are to convert from high level language to binary code here. Yes, interpreter and compilers are used to convert from high level language to binary codes. Okay, here the difference is, let us see. Yes, comparison of these two things here. Yes, interpreter, yes, versus compiler. Interpreter versus compiler. What's the difference between these two? Interpreter and compiler. So first let us see about interpreter. Yes, let us see about interpreter. So interpreter. Yes, for interpreter. Yes, let us see about Python. Python example. Python is a best example of interpreter based language. Python is a best example of interpreter based language. Support test Python 15. Okay. So interpreter versus compiler. So interpreter. Yes, Python is an interpreter based language. Like this, we have many interpreter based languages. Python is a best example. Python is a best example. Python is a best example. Yes. Let us see Python. Yes, Python scripting. D drive. Some test folder. So D drive test folder. D drive test folder. Yes, in this CMD command prompt, G colon, that will take to D drive. So D drive test. So D colon means will take to D drive. DR some output. Not test, it's a directory. So directory folder both are same. Directory folder both are same. So directory folder both are same. See, GA, yes, GA calling as folder. Same thing, character interface calling as directory. It's a directory. It's directory. Okay. Yes, GA calling as folder. In GA calling as folder, in character interface calling as directory. GA it's a folder. In character interface directory. Both are same. Both are same. Both are same. So both are same. Okay. Yes. In GA it's a folder. In character interface directory. Folder and directory. Okay. Both are same. Both are same. No difference here. Both are same. Both are same. Both are Same. Yes. So in GA calling as folder, same thing, character interface calling as directory, both are same. Now see here, test it's a directory, dir means directory, it's directory, test is a directory, test is a directory. Okay, now we should go to test directory. CD, change of directory, CD test, CLS clear screen here, dir some output here, dir shows the contents of, yeah, this one shows contents, this one shows contents of D drive, yeah, test folder, test folder. Okay, so this one shows the coordinates of test for dir, CLS, dir. So test for 0 files, 0 bytes, no data, no files here. So dir test folder, yes, 0 files, no files, empty folder, it's empty folder. Now here let us write one Python script here, just notepad. Yes, here actually Python scripting means we have PyCharm actually. PyCharm ID. In real time using PyCharm ID. In real time using, yes, PyCharm ID. In real time using PyCharm ID. Okay, for better understanding, I'm using simply Notepad. Simply I'm using Notepad. Yes, Notepad test.py. Yes, so Python scripting for Notepad test.py. Do you want to create new file? Yes. Okay. Yes, in this first A is equal to 10. So B is very simple script. B is equal to 20. Okay, C equal to A plus B, A plus B. So print addition of these two numbers, addition. Yes, addition is equal to, say, displaying C. Okay, right? Yes, A equal to 10, B equal to 20, C equal to A plus B, print addition equal to C here. Okay, next. Yes, C equal to A minus B, C equal to A minus B, A minus B. Addition equal to C. Yes, addition or subtraction is subtraction. Or subtraction. It's a subtraction. Subtraction equal to C here. Next, C equal to A into B. So next, C equal to A into B. C equal to A into B. A into B. Subtraction. Next, multiplication. Next, multiplication. Yes, multiplication. Okay. Yes, C equal to A plus B, addition. C equal to A minus B, subtraction. C equal to A into B, multiplication. Right. So this is simple script here, very simple script. Addition, subtraction, multiplication. How the script is working? Let us see about the script. How this is working? Control S, save it and exit. Not dir, check it. CLS, dir. Okay. So test.py, the script, Python script here. So test.py. Now let us run it here. Yes, Python is test.py. Run it. Yes. Addition equal 30, subtraction equal minus 10, multiplication equal 200. Addition equal 30, subtraction minus 10, multiplication equal 200. That's it here. So addition, subtraction, multiplication. So 30 minus 10, 200 like this. So this is working. Working is like Python script working is like this. Now, suppose some mistakes, any mistakes are there, what happens here? A equal to 10, B equal to 20, C equal to A plus B. Addition. Suppose here comma missing. What happens? Suppose here double quotation missing, what happens? Here bracket missing, what happens? Totally there are three mistakes. There are three mistakes. Okay, CLS, now run it here. Yes, run it. Yes, see this. Showing only one error. Actually, total three mistakes are three errors are there. See here, A equal 10, A equal 10, A equal 10. So A equal to 10. Once someone is facing issues, yeah, just a minute, someone facing issue to join. Yeah. A equal 10, B equal 20, addition, C equal to, yes, addition. Here one mistake is there. Next here one more mistake, here one more. Totally there are three errors. Totally, there are 3 errors in the program. 3 errors in the program. Okay. So when you run it here, run the script here, Python script. Python test.py. So run it here, Python. Run it here. Yes, see this. Addition equal to only one error showing. Yes, it is showing only one error. It is showing only one error. Yes, here showing only one error. Now what happens here? See how that interpreter is working. Let me explain clearly how interpreter is working. How interpreter is working. See how interpreter is working. See here program statements like this. Program Python script is like this. Yes, first statement a is equal to 10. A is equal to 10. Next statement b is equal to 20. These statements, same statements I'm explaining here. Just imagine like a equal to 10. So this is b equal to 20. Next c equal to a plus b statements. So print addition equal to c equal to a minus b. Okay, print subtraction equal to okay, next subtraction equal to next c equal to yes a into b. Yes, next multiplication equal to right. Yes, how it's working. Now interpreter. Python interpreter checking first line. Yes, checks for the first line. Checking first line here. Checking first line. First line. Yes, if it is correct. Yes, it converts into Bandicoot. It converts into Bandicoot. Bandicoot zeros format. Yes, the Bandicoot given to processor. So processor is taking the Bandicoot and generating output simply. So here interpreter checks the first statement. Interpreter checking first statement. Interpreter first checking first statement. If first statement is correct, converts into binary format. Interpreter checking first statement. If first statement correct, converts into binary format and given to processor, generating output. Generating outputs. Next checking for next statements. Checking for next statements. Checking for next statements. Suppose next statement also correct. Next statement also correct. Okay, simply converts into binary format, zeros ones format. Okay, yes, given to processor. So processor generating outputs. Like this, checking first statement if correct, converts into binary code, generating output immediately. Yes, checking for next statement if it is correct, converts into binary code. Yes, given to processor, then generating output here. So like this line by line checking. First one checking if it is correct, immediately execution. Next one checking if it is correct, immediately execution. Next one checking, suppose something wrong, simply stops here. Something wrong, stops. Something wrong, stops here. Any error comes, interpreter stops. That's it here. Okay. Yes, it shows only one error. Interpreter shows only one error. Interpreter shows only one error. Now let us correct that mistake. Seventh line error. Line number 7 error. Line number 7 error. See here. I'm using up arrow key to get the previous commands. Up arrow key to get the previous commands. Up arrow key. Okay. Yes. See this. Yes. Now you can correct that mistakes. Comma. Right. Yes. Next step. See. Right. Subtraction is equal to so 11th line error. 11th line error. Okay. So like this, yes, checking next 11th line, yes, correction this is here. So whenever error comes, simply stopping. It's not moving to next line. Whenever error comes, simply stopping. So when error comes, simply stopping. See this. Yes, 17th line error. 17th line error. 17th. So again, this is like this, showing only one error. Okay. Yes, now save and run it. Yes, now it's working. So this is working of interpreter. Okay. So interpreter checks the script line by line. First line checking, then converting to binary code, then executing. Next line checking, converting to binary code, then executing. Next line, any error comes, stops. Any error stops. Any error stops here. Any error simply stops. Okay. So any error comes, simply stops. Checking first line. Yes, if it is correct, then executing generate outputs. Checking next line, if it is correct, simply generating output here. So next line something wrong, simply stops. So this is about interpreter. So working of interpreter is like this. Okay. So working of interpreter is like this. Okay. So working of interpreter is like this. Right? Yes. Next is compiler. Let us see about compiler. Yes. Yes, for the compiler, let us take C program. For compiler, let us take C program. Compiler. How compile is working? Yes. Compiler. Yes. 1 second. Compiler. 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 Yes. C program. Suppose C program. S.C. Yes. Let us take compiler. Yes. C program. How C program is working? Yes. 1 second. C program is a compilable. C is a compilable. See this S.cpp. CPP and C both are same. CPP means C++. C++. This is C++. C++ and C compile both are same. C++ compile using for both C as well as C++. C++ compile using for both C as well as C++. C A equal to 10, B equal to 20, into C equal to A plus B. Yes, here addition, subtraction, next multiplication. Okay, same program in C language. Same previous example, what we discussed in Python scripting, same in C programming. Same in C programming. Yes, let us compile. Success, no errors. Errors, zero errors, no errors. No errors. Now run it. Yes, addition equal 30. Subtraction equal minus 10. Multiplication equal 200. Addition 30, subtraction minus 10. Multiplication 200. Addition, subtraction, multiplication. Right? Okay. Yes. So this is yes. C program. Let us do some mistakes here. Suppose there are some mistakes. What happens? Suppose here semicolon missing. Suppose here some bracket missing. Okay. Yes. Here suppose double quotation missing. Okay. Yes. Here, for example, here semicolon missing. Okay. Here, for example, comma missing. There are some missing statements. What happens here? Suppose here bracket missing. Let me save it. Save it here. Compile it. See this. Yes. It's showing all the errors. 10 errors here. 10 errors. Showing all the errors. See the first error. 10th line error. Next 12th line error. 30. Yes. See at the bottom. Look at the bottom. Look at the bottom. 10th line error. 12th line error. 14th line error. 16th line error. Yes. Next 22nd line error. 24th line error. 26th line error. 28th line error. All these errors here. Right. So this is compile working. Let me explain clearly how compile works. How compile working? Yes, how compile is working. See, compiler checking first statements. Compiler checking first statements. Suppose first statement is correct. Even correct, it won't convert into binary code. No, it won't convert into binary code. Yes, even first statement correct, it won't convert into binary code. Next, checking second statement. Checking second statements. Second is statement also correct. Even correct, it won't convert into binary code. Even correct, it won't convert into binary code. Hello. Tell me. See, compiler checking for the first statement. Okay, suppose correct, then go to next statement. Next statement also correct, then go to next statement. Suppose something wrong here. Something wrong. It shows error at some line. Error at third line. Compiler shows that error at some line. Yes, after go to next statement also. Checking for next statement also. Checking for next statement also. Checking for next statement. So next statement also correct. Then go to next statement. Okay. So checking for next statement. Checking for next. Suppose next statement also correct. Go to next statement. Okay. Suppose something wrong. Something wrong. Error at some line here. After that, Yes, go to next statement. Okay. So next checking for next. So top to bottom, compiler checks whole program from top to bottom. Compiler checks whole program from top to bottom. Compiler checks whole program from top to bottom. Okay. Yes, and shows all the errors. Compiler shows all the errors. See, interpreter, what happens here? Line by line. First line checking, then execution immediately. Second line checking, then execution immediately. If any error comes, it stops. Yes, interpreter shows only one error. 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 Okay. So interpreter shows only one error. Okay, right? Yes, compiler shows all the errors from top to bottom. So interpreter checking line by line and shows only one error. Any error comes, simply stops. Simply stops. But compiler is not like that here. Compiler checks whole program from top to bottom and shows all the errors. See that? Compiler. Yes, now this is showing all this. Compile. See this. Totally 10 errors. 10 errors. Okay. So 10th line error, 12th line error. See, look at the bottom. Look at the bottom here. 10th line error, 12th line, 14th line, 16th line error. All the errors from top to bottom. All errors from top to bottom. So compiler shows all the errors from top to bottom. Okay. Now correct the mistakes here. Correct the mistakes. Yes. Semicolon. Semicolon. Correction of mistakes. Semicolon. Semicolon. Yes. Yes. Bracket here. Next here. Double quotation missing here. Correct. Yes. Here. Bracket missing. Correct. Yes. Some errors correction is done here. Now save it. Yes. Overwriting. Overwritten. Now compile again. Yes. Still two more errors. Errors. Two more errors. Two more errors. So this is error here. So this statement semicolon missing here. Next here comma missing. Comma missing. Now save it. Saved. Yes. Yes. Compile. Yes. Compiled. Success. 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 Right. Compiled. Success. If no errors, then what happens? Let us see. Yes. Here don't have any errors. Okay. So compiler checks whole program from top to bottom, shows all the errors. Compiler checks whole program from top to bottom and shows all the errors. 1 minute. Let me have some water. Yes, compiler. It checks all the statements from top to bottom and shows all the errors. Shows all the errors. And shows all the errors. Okay. Yes, next the correction of all the errors. See, after correction of all the errors, after correcting all the errors, yes, next again checking. Suppose next time no error, everything is fine. Everything is fine, then what happens here? Top to bottom checking. Compiler checks whole program from top to bottom. Suppose no errors. See that? Yes, compile. Success, no errors. Success. What she comes? Success, success. Success, no errors. No errors. Yes, if no errors, then what happens here? If no errors, compile opens one file. Compile opens another file. Compile it opens another file here. This whole code converts. Yes, that converts from C program to binary. Means source code. Source code. This is called as source code. This is called as source code. Okay, that whole code converts into binary form. So this high level language, C program, high level language. C program, it's high level language, right? Whole this program from high level language to binary code converts into binary codes. 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 So that whole code converts into binary format. Whole code converts into binary format. And write to another file. And write to another file. Here, this file is called as exe file. So this will generate a test.exe file. It will generate text.exe file. Test.exe file. Okay, it generates test.exe file. Okay, compiler checks whole program from top to bottom. Compiler checks whole program from top to bottom. Okay, yes, compiler checks whole program from top to bottom and converts in binary code. Yeah, tell me. Yeah, I know that. Tell me. Actually, I'm in class. I will call back. Okay. Yes, compiler converts this whole code into binary format, right to some another file called as text file, is exe file. So compiler checks whole program from top to bottom. Compiler checks whole program from top to bottom. After it converts into binary code and write to another file. Write to another file. Here this file is called the exe file. That exe file submitted to processor, submitted to processor, submitted to processor. So processor taking that exe file. So processor taking that exe file, generating output simply here. Okay. So compiler checks whole program top to bottom. If no errors, everything is fine. Converts in binary format, write to another file. This file is called as exe file. Yes, exe file given to processor, generating outputs. Generating output simply. Okay, let me show that exe file also. So backend of this program. Just for this program backend. Yes, one second. C drive. C drive and C this is turbo C DC. Turbo C. TC. TC here bin. Yes. What is name of the program file? Test.cpp. Test.cpp. So test T. So T is coming here. So test.cpp. Test.cpp. One second. Let me delete all the old files. There are some old files. Delete all the old files. Deleted here. Test.cpp. Okay. Now let us compile this program. Compile. Next run it. So when you run it here, something happens back and run it here. When run it here, just observe here. Here observe something happens here. Run it. See this. Yes, here back end. Yes, another file created. 1710 today at 11:09 a.m. Just now created. What is this file? Let us check the extension properties. What is extension.exe? That's it here. S.exe file created. So your application image exe file. Application image exe file. So for test.cpp exe file generated. That exe file executed. That exe file executed. That exe file executed. See that? Got the output right? Yes, again run it. Again run it. Run it. Yes. Again exe file created. Yes, run it. Okay, so here when you try to run it here, first of all, you create exe file. C compiler, first of all, creating exe file. Yes, that creating exe file. So exe file created and executed it. Okay, yes, compile. Yes, success. Compiled. Yes, now run it here. Yes. That exe 11:10 a.m. Again exe regenerated. Then timestamp generates. That's it. So what happens here? Yes, compiler generates one exe file, that exe file executes. That's it. So this is about compile interpreter. Okay. Yes, compile interpreter. See, yes, interpreter line by line checking, then execution. Any error comes, simply stops. Line by line checking, then execution. Checking line, then execution. Next line checking, then execution. Next line, any error stops. Next line, any error stops. Okay. Yes, if it is compiled, how it's working here. Yes, checking whole program top to bottom. Whole program from top to bottom. Suppose everything is fine. That whole code converts into binary formats. That binary formats. Yes, write to another file. That result file is called an exe file. That result is a exe file. That exe file given to processor. So generating outputs. Okay, one second. This guy facing issue by yes, Chandrasekhar, rejoin session. Yes, rejoin session. Chandrasekhar, rejoin session. Yes, he has to rejoin. Yes, okay. So let us continue. Now, interpreter compiler. Tell me guys, what's the difference observed here? See, this is interpreter page. In this page, interpreter expand, this page compile expand. What's the difference between these two pages you observed here? Interpreter expansion and compile expand. What's the difference you observed here? Tell me, what's the main difference you have observed here between interpreter and compiler? See, in this page, interpreter explained, in this page, compiler explained. What's the difference between these two you observed here? Tell me. What's the difference between these two you observed here? Tell me, guys. What's the difference you have observed here? In this explanation, what's the difference you observed? Yes, no different subject. Yes, what's the different subject here? Yes, okay, fine. Okay, I'll explain. No worry. See, what's the difference here? See here, yes, interpreter simply checking line balance and executing, right? Interpreter checking line balance and executing. See, in case of compiler, what happens? In case of compiler, what happens? Compiler checking whole program from top to bottom, and this whole code converting to binary format right to another file. This whole code converting to binary format right to another file. This whole code converts in binary format right to another file. This file is called exe file. So this compiler generating exe file. Okay, compiler generating exe, interpreter don't have exe, right? Yeah, okay, fine. Praveen, fine. Interpreter stops in here, but compiler shows all fine. Main important difference is here. Main important difference is exe file. Main important difference is exe file. Yes, let us see. Compiler versus interpreter. Yes, interpreter versus compiler. See, interpreter versus compiler. Interpreter versus compiler. See, interpreter versus compiler. Yes, let us see the differences here. Interpreter versus compiler. Okay. See, interpreter versus compiler. Interpreter, compiler. Right? Yes. Let us see. First difference. Interpreter. It checks the codes. It checks the codes line by line. It checks the code line by line. Yes, interpreter checks the code line by line. It checks the code line by line. Yes, compiler. It checks whole program from top to bottom. It checks whole program from top to bottom. From top to bottom. So interpreter it checks the code line by line. Interpreter it checks the code line by line. Interpreter it checks the code line by line. It checks the code line by line. Compiler it checks whole program from top to bottom. Okay, interpreter it checks the code line by line. It checks the code line by line. Compiler it checks whole program from top to bottom. Right? So interpret is line by line, but compare is complete code from top to bottom, right? Yes, next. When come to output here, yes, it generates. So interpreter generating output line by line. Output or line by line here. So interpreter generates yes, output line by line. Output line by line. Yes, interpreter generates output line by line. It generates output line by line. It generates output line by line. Compiler, yes, whole program at a time. Yes, whole program at a time, whole program at a time. Okay, so compiler, whole program at a time. Okay, whole program output at, because exe file, right? Compiler generating one exe file, compiler generating one that exe file executing, compiler generating one that exe file executing. So at a time output, it's at a time output here. Interpreter, it generates output line by line. It generates output line by line. Compiler whole program at a time, right? Yes. Next difference. Next difference here. Yes, interpreter shows only one error, but compiler shows all the errors from top to bottom. Yes, interpreter it shows only one error, only one error, only one error. Interpreter shows only one error, but compiler, yes, it shows all errors from top to bottom, all errors from top to bottom, from top to bottom, from top to bottom, top to bottom, right, top to bottom. Okay. See, interpreter, it shows only one error. Interpreter shows only one error. Next, compiler, it shows all errors from top to bottom. Yes. Next, main difference exe. Here, main difference exe file. Yes, interpreter, it does not generate exe file. It does not generate exe file. Okay. Yes, interpreter, it does not generate exe file. It does not generate exe file. Compiler, it generates exe file. It generates exe file. So this is main difference. Okay, interpreter, it does not generate exe file. It does not generate exe file. Compiler, it generates exe file. It generates exe file. So interpreter does not generate exe file. Compiler generates exe file. Okay, right? Yes. Next difference. See here. Interpreter, what is happening here? Interpreter, what is happening here? See, Python SWI directly script executing, right? Yes, Python script executing directly. Okay, that source code executing directly. Yes, this is called a source code. Yeah, this is source code. This is source code, right? It's a source code. This source code executing directly here. This source code executing directly. See that executed directly. Source code executed directly. Source code executed directly. So executing that source code directly here. But in C language, what is happening here? Compiler, first of all, creating exe file, that exe file executing, exe file executing, exe file executing. Okay, right? Interpreter, it executes source code directly. It executes source code directly. Okay, interpreter, it executes source code directly. It executes source code directly. Yes, compiler. Yes, it executes exe file. It executes exe file. It executes exe file. It executes exe file. Okay, interpreter, it executes source code directly. It executes source code directly. Okay, source code executing. See this, that source code executing directly, but compiler, whatever behind of this one exe file generated. S.exe file, that exe file executed. Okay, yes, it executes exe file. It executes source code, it executes exe file. Okay, right? See, interpreter based. All interpreter based languages are scripting language. Okay, see, all interpreter, all interpreter based languages are called as scripting languages. Okay, all interpreter based languages are called as scripting languages. All interpreter based languages are called as scripting languages. So all interpreter based languages are called as scripting language. Yes, compiler based are called as programming language. Yeah, these are called as compiler. They are called as programming languages. These are called as programming language. They are called as programming languages. Okay. See, interpreter based languages are called as scripting language. So these are called as scripting language. These are called as programming language. Okay. So interpreter based scripting language, compiler based programming language. Suppose, for example, here, for example, yes, Python is a scripting language. Python is a scripting language. Next, HTML is a scripting language. Next, JavaScript. JavaScript is a scripting language. Okay. So interpreter based language examples Python, HTML, JavaScript. Okay. Next, PHP is Perl scripting. Okay. PHP, Perl scripting, Linux shell scripting. So these all are scripting language. So these are scripting language. Okay. Yes. Programming language examples. Examples. Programming language. Okay. C and C++. Okay. Next. .NET. .NET. C Sharp. .NET C Sharp. So these are scripting language. These are programming language. Okay. Yes. See here different. Let me clear once again here. Let me repeat once again. Yes. Interpreter compiler. Interpreter checks the code line by line. Yes, compiler whole program from top to bottom. Whole program from top to bottom. Interpreter it generates output line by line. So output also line by line. Yes, here at a time output because of exe file. At a time executing and generating outputs. Next interpreter, it shows only one error. It shows only one error. Compiler, it shows all errors from top to bottom. Yes, it shows all errors from top to bottom. Okay, so main difference 4 and 5. These two main differences. Yes, it does not generate exe file. Yes, it does not generate exe file. It generates exe. So that exe file is a difference here. So interpreter does not generate exe file. Compiler generates exe file. Right? Okay. Next, interpreter it executes source code directly. It executes source code directly. Source code executes directly. But compiler it executes exe file. It executes exe file. Okay, right? See, all interpreter based language. So these are called as these are called as scripting language. These are called as scripting language. Scripting language. Next, these are compiler based. Compiler based called as programming language. Scripting language examples: Python, HTML, JavaScript, PHP, Perl scripting, shell scripting. The scripting language. Okay. Yes, compiler. So this is a compiler based language. C++.NET. Okay. See, finally some conclusion. Yes, interpreter compiler differences. Yes, finally some conclusion here. See, interpreter. Yes, interpreter based language. Interpreter based language don't have exe file. Interpreter based language don't have exe file. See, interpreter based language don't have exe file. Interpreter based language don't have exe file. Okay. Yes, interpreter based language don't have exe file, but compiler everything is in exe. So finally creating exe file. Okay. So everything is an exe file only here. Everything is an exe file. Compiler based. Okay, compiler based. It's exe file concept. Everything is an exe file. Everything is an exe file. That's the difference. Okay, fine. So this is interpreter compiler differences. Okay. So interpreter based language examples, compiler based language examples. Okay, fine. So fine, all are fine. Now here's some doubt here. You guys getting some guides, some doubts. You guys are getting some doubt. I think here. I think some doubt for you. Yeah, this Rao trainer is explaining about all things like compiler, interpreter, and about Python, C, C++, many things. But he's not talking about Java. It is Java. Yes, 100% you'll get this doubt too. Yes, this Rao is explaining everything fine, but he's not explaining about Java. So what is Java? Is it interpreter based or compiler based? Yes, let us see. Now let us start Java. Now I'm starting Java. Yes, Java. Yes, Java. Yes, is it interpreter based or compiler based? Is it interpreter based or compiler based? Or both? Or both? Yes, anyone idea about it? The Java, is it interpreter based or compiler based or both? Yes, what is Java? Is it interpreter based or compiler based or both? Yes, anyone idea about it? No idea. Okay, I'll explain. See, first I'll explain about Java, then you decide it finally. Okay, first I will explain about Java, then you decide it. Yes, Funny saying that both. Shravanti saying that interpreter. Shravanti, interpreter. And both. Okay, fine. Now let us see Java. Yes, about Java. See, except Java in other languages. Except Java in other languages, what happens here? Except Java in other languages. First of all, source code. Except Java in other languages, what happens here? Source code. I mean, this is source code. For example, this is source code. Yes, your Python script is a source code. This is source code. This is source code. Next C program, it says so. This is source code. But English language could high level language. Source code. This high level language is source code. It's a source code. It's a source code. It's a source code. Okay. Yes. Now what happens here? Yes, the source code converts into binary codes. Source code converts into binary codes. Yes, source code converts into binary codes. Source code converts into binary codes. After converting into binary codes, the binary code given to processor. Binary code given to processor. Binary code given to processor. So processor taking that binary code generating output. See here, source code to binary code by the compiler or interpreter. Suppose C language. If it is C language compiler converts source code to binary codes. C language compiler converts source code to binary codes. C language compiler converts source code to binary codes. C language compiler converts source code to binary codes. Right? C language compiler converts from source code to binary codes. Suppose if it is Python, interpreter converts from source code to binary code. Suppose HTML, interpreter converts source code to binary code. So either compiler or interpreter converts from source code to binary code. That's a case of other language. Yes, Java. So in Java, what happens? Let us see about in Java. Java, what happens here? So first of all, source code converts into binary code. Source code converts into binary codes. Then, sorry, not binary. In Java, what happens is a byte code. In Java, what happens here? First of all, source code converts into byte code format. Yes, what is byte code? We'll discuss. Wait. Yes, I'll explain practically. What is bytecode? We'll show. I'll show practically here. In Java, what happens? Source code to bytecode. That bytecode now converting into binary codes. That binary code given to processor. So finally generating output. Okay. Yes, source code converting to bytecodes. That bytecode converting to binary codes. That binary code given to processor generating outputs. So this is what is happening in Java here. Okay, what is bytecode here? Here bytecode. See, why bytecode introduced in Java? See, bytecodes. Yes, bytecodes. Bytecodes was introduced. Because bytecode was introduced. Yes, introduced to make Java as independent platform. Independent platform. Okay. Yes, bytecode was introduced. Bytecode was exactly what is bytecode we'll discuss. Once Java programming started, I'll show bytecodes. Once Java programming started, I'll show the bytecodes. See here, in Java, what happens? First of all, source code converts into bytecodes. Next, bytecode to binary code. So there are two steps happens here. Java, two steps. See, other language only one step. Source code to binary code directly, but in Java it's a two steps. First source code converts in byte code. So first source code converts in byte code. Next byte code converts in binary code. Source code to byte code. Source code to byte code. Yes, source. Yes, source code to yes byte code. This is by the compiler. Java compiler. This is by the Java compiler. Java compiler. Source code to byte code. Source code to byte code by the Java compiler. Source code to byte code by the Java compiler. Correct. Next, this step byte code to binary format. Byte code to binary format with Java interpreter. Byte code to binary code with Java interpreter. Java interpreter. Java interpreter. Java interpreter. Interpreter. Okay. Source code to byte code by the compiler here. Source code to byte code by the Java compiler. Byte code to binary code by the Java interpreter. Yes, let us see Java program also, like Python example. Let us see Java program also. Java program. Yes, D drive, suppose sample folder. Sample folder. Yes, once exit, closing terminal. CMD command prompt. Open a command prompt. Open a command prompt. Yes, from the command prompt now, D drive sample folder. Yes, we should go to sample, D drive sample. Okay. So D colon. Yes, taken to D drive. DR output. Sample. Yes, sample directory, sample directory. Direct CD change of directory. Sample changed the year. The 0 files 0 bytes. 0 files 0 bytes. 0 files 0 bytes. 0 file 0 bytes. Note that empty folder, it's empty folder. Okay, now here let us write one Java program. For easy understanding purpose, I'm taking Notepad. Okay. So actually our daily classes in Eclipse. Okay. So till now we have not discussed anything about Eclipse. So I'm using Notepad. Our daily Java program with Eclipse only. Our daily classes are using Eclipse, but here till now Eclipse installation not expand, so not using Eclipse. So I'm using Notepad. I'm using Notepad to develop the simple Java program. Yes, I'm using Notepad. Yes, Notepad. Test.java. Test.java. Notepad test. Yes. Do you want to create new file? Yes. I'm writing very simple Java program. Public public class test, public class test, starting ending. Okay. Yes, public static void main method, public static void main method, string square brackets box. Okay. System dot yes out dot println, system dot out dot println hello world, hello world, right? Yes. See public class test. Public class test here. Public static void main string square bracket talks here. System dot out dot print hello world. So this is simple Java program. See, our topic is not about Java program. Topic is about compiler interpreter. About this program later I will discuss. About this program later I will explain. Just topic about interpreter compilers here. Save. Exit. No. DR. See, test.java just now created 11:36 a.m. here. No compilation. Java C. Yes, compilation test.java. Yes, compiled DR. See this dot class file generated. Java C means Java compiler. Java compiler taken test.java and check it for all errors. Here no errors. Dot class file generated. Dot class file generated. Okay. Yes. No. See. So test.java. Test.java is a source program. It's a source. Test.java is a source. It's a source. Sorry. Yes, it's a source code. It's a source code. Source code given to Java compile Java C. Okay. Test.java. It's a source code. Test.java. It's a source code. The source code given to Java compiler. Now Java compiler checking whole program from top to bottom. After checking no errors, generated one dot class file. Generated a dot class file, right? Yeah, this is bytecode. It's a bytecode. It's a bytecode. It's a bytecode. It's a bytecode. Okay. Test.java. Test.java. Test.java source codes given to Java compiler. Java compiler checking whole program from top to bottom and generating dot class file. If no errors, generates dot class file. Bytecode file. Here that bytecode file given to Java interpreter. Java interpreter. Java interpreter. Java interpreter. Okay. Java interpreter taking dot class file and converting into binary code line by line. Interpreter converting into binary code here. It converts into binary code. It converts into binary code. Yes, but binary code given to processor generating output finally. Generating output finally. That's it here. So what is happening here in Java here? Source code to bytecode by the Java compiler. Series test.java. Source code given to Java C compiler. Checking from top to bottom. Okay. Generating one bytecode file. So generated bytecode file. Right? See that dot class file. CLS TR. See, after compilation, result file is dot class file. It's a bytecode file. See, I'm recompiling 1 second. Yes, just I'm recompiling. Yes, compiled. No check it. Test recompiled. No errors. No dot class. Just not generated dot class file. So 11:39 a.m. 11:39 a.m. Just not generated. Test dot class. Test dot class, right? So this part is over. So test.java given to Java compiler. Checking for all the errors. If no errors, generated dot class file. Now what happens here? Yes, in Java errors. Checking by the compiler. Checking by the compiler. If no errors, yes, if no errors, it generates dot class file. It generates dot class file. Generates dot class file. It generates dot class file. If no errors, it generates dot class file. If no errors, generating dot class file. No errors, generating dot class file. After generating dot class file here, now this dot class file taken by the interpreter Java test on it. Yes, executed hello world. So here Java C means Java compiler. Java C means it's compiler. Java C means it's a compiler. Java means it's interpreter. Java C, it's a compiler. Java means interpreter. That's it here. Okay, so compiler checking program top to bottom. No errors generated one dot class file here. The dot class file executed by the interpreter. So you get Java sim Java compiler. Java means it's the interpreter. Okay. Yes, errors checking by the compiler, but program execution by the interpreter. Program execution by the interpreter. Okay, in Java, yes, errors checking by the compiler. If no errors, it generates dot. If no errors, it generates dot class file. If no errors, it generates dot class file. If no errors, it generates dot class file. Okay, right? Yes. Next, the Java program. See Java program dot class file. Dot class file executing Java program dot class file. Java program dot class file. Java program dot class file. Yes, Java program dot class file executing by the Java interpreter. Yes, executing by the Java interpreter. Java interpreter. Java interpreter. Executing the Java interpreter. That's it here. Okay. See Java errors checking by the compiler. If no errors, generates dot class file. Get the dot class file executing by the interpreter and generating output finally. So errors checking by the compiler, then execution by the interpreter. Now tell me finally here. Yes, is it compiler based or interpreter based or both here? Tell me guys, finally conclusion. Come to some conclusion. Now come to some conclusion. Come to some conclusion. Yes, Java. Is it interpreter based or compiler based or both? Yes, it's a both. It's a both. Okay, Java depends on Java depends on yes both Java depends on both compiler both compiler as well interpreter depends on both compiler as well interpreter okay interpreter. So Java depends on both compiler as well interpreter. Java depends on both compiler as well interpreter. Okay, that's it, right? Yes. Here. Okay, fine. So this is about Java. So in Java here there are two stages here: source code to bytecode to binary code. In Java, bytecode was introduced to make Java is independent platform. Yes, we'll discuss what is independent platform. I'll explain here. Source code to bytecode by Java compiler, bytecode to binary code by the interpreter. There are two things involving here. Okay, so two things. So Java errors checking by the compiler. If no errors, generates dot class file. Yes, next dot class file executing by the Java interpreter. Java program execution by the interpreter. Okay, Java depends on both the compiler as well interpreter, right? Okay. Yes, here some question for you guys. Some question from this explanation. Try to answer some question here. Some question is, yes, can we create exe file in Java? Can we create exe file in Java? Tell me guys, can we create exe file in Java? Anyone can you answer this? See, as per this explanation, anyone can you answer? Can we create exe file in Java? Yes, can we create exe file in Java? Can we create exe file in Java? See this. In this process, have we observed any exe file? See, Java program explained very clearly. So first notepad, using notepad writing .java file. Of writing .java file, next a compilation Java C test.java compiled. After that result is dot class file generated. After dot class file executing Java test executing. Yes, executed. In this process, have you observed any exe file? In this process, Java program developed, compiled, executed. Have you observed any exe file? Yes, hello guys. Yes, these are the steps. In these steps, have you seen any exe file? Dot class is not exe. Dot class is different. Exe file is different. No exe file. Yes, there is no question of exe files in Java. Java don't have exe file concept. Java is independent platform. Suppose if it is exe file, that is OS dependent. But Java is independent platform. Okay. So because of this reason, don't have exe file. Java don't have exe file. So there's no exe. There's no concept of exe file in Java here. Okay. Yes. Answer is no. Answer is no. Okay. Yes. We can't create exe file in Java. Yes. Java. Yes. Don't have. Java don't have. Yes. Concept of exe files. Java don't have concept of exe files. Okay. See here. See. Any programming language. Try to remember this one here. Any programming language. Yes, program execution by the interpreter. Okay, any programming language, execution by the interpreter. Yes, don't have exe file concepts. See, any programming language execution by the interpreter, the program execution by the interpreter don't have exe file. Okay, yes, here Java. When come to Java, since Java program execution by the interpreter. Java program execution by the interpreter don't have exe file. Yes, don't have exe file concept. Yes, since Java program execution by the interpreter. Don't have exe file concept. There is no concept of exe file. Java don't have exe file. Okay. Yes, since Java program execution by the interpreter Java interpreter don't have exe file. Okay. See, in Java everything. Yes, everything is a dot class file. Everything is dot class file. Java everything is dot class file. Okay, but dot class is not exe file. Dot class file is not an exe file. Dot class is not an exe file. So dot class is different, exe file is different here. Dot class is not an exe file. Okay, see exe file is a binary code file. Exe file is a binary code file. Exe file is a binary code file and it is a system understandable language. It is a system understandable language. It's a system understandable language. Okay. Yes, exe file is a binary code file. Exe file is a binary code file and it's a system understandable language. Okay, what is dot class? See dot class file. See dot class file is a bytecode file. It's a bytecode file and it's a JVM understandable language. It's a JVM understandable language. JVM understandable language. Okay. Yes. Exe file is a binary code. Exe file is a binary code file and it's a system understandable language. A dot class file is a bytecode file. Dot class is a bytecode. Yes, what is bytecode? We'll discuss in Java programming. Once Java programming started, we can see a bytecode. Dot class file is a bytecode file. It's a JVM understandable language. Next, one more thing here. See, exe file is a OS dependent. Exe file is OS dependent. Exe file is a OS dependent. But dot class file, see, dot class file is an independent of OS. Is an independent of OS. Independent of OS. Exe file is OS dependent. A dot class file is an independent of OS. Exe file dot class. So that's a difference. Okay. Yes. More about exe file dot class difference is tomorrow class topic. Tomorrow topic is about independent platform topic. Tomorrow topic is about independent platform. Portable, all the Java features. Till now, all these basics completed. Till now, all the software basics. See the software basics. Introduction to software, system software, application software. Next about OS. Okay. Next about front end, back end. About language packages. Okay. Next about low level, high level languages. Generation of computers. Low level, high level languages. Okay. Next about interpreter and compiler. Yes, all these were discussed. Next about Java introduction given. Java introduction. Okay. Java depends on both compiler as well interpreter. Okay. Java errors checking by the compiler. Yes, dot class file is bytecode file execution by the interpreter. It's the same steps. Okay, right? Yes, here. So here Java compiler. Yes, source code to bytecode to binary code. Bytecode to binary code, finally generating output. Okay, same thing explained here. Yes, source code to bytecode to binary code, processor then output, right? Source code to bytecode by Java compiler, bytecode to binary code by the interpreter. Okay. Yes, bytecode was introduced to make Java program as independent platform. Okay. Yes, Java depends on both compiler as well interpreter. Java runtime is an interpreter based. Okay. See, any language runtime is an interpreter based, no exe file. Yes, since Java runtime means execution. Java runtime is interpreter based, no exe file concept in Java. No exe file concept in Java. See this? Can we create exe file in Java? No. Yeah, there is no concept of exe files in Java. In Java, everything is a dot class file. Everything is dot class file. Dot class file is not an exe file. See, exe file is a binary code file and it's a processor understandable language. It's a processor understandable language. Dot class is a bytecode file. It's a JVM understandable language. Exe file is OS dependent. Dot class file is independent of OS. Yeah, this topic difference between .exe .class file tomorrow getting. Tomorrow .exe file .class file differences. How Java made us independent of platform. Yes, tomorrow topic is about independent of platform portability, that features. So once this is completed, next Java installation. Yes, once these features completed, Java installation. So tomorrow we'll discuss about executable dot class for differences. Yeah, there are many differences. There are many differences between executable dot class. So tomorrow class we'll discuss. Tomorrow class I'll explain. Yeah, that's all for today. Yes, any doubts, guys? Any doubts? That's all for today. Any doubts? Yes, guys, any doubts? Yeah, that's all about introduction. All the introduction completed, software introduction completed, Java introduction also completed. Yes, next about Java features and Java installation. Yes, tomorrow Java installation topic will be there. Yes, next programming starts. Up to this, all introductions completed. Yeah, that's all for today. That's all. Yes. No. Java don't have exe file concept. Okay. There's no way to create exe file in Java. No exe file concepts in Java because Java is independent platform. So once exe file created, the Java becomes platform dependent. Suppose if you're able to create exe file, that exe once exe is generated, it's a platform dependent. The topic tomorrow I will explain. Tomorrow we'll get more clarification on this here. Independent platform exe file dot plus file. Tomorrow getting more clarification on this. Tomorrow, yes, will be clear. Okay. Yeah. That's all for today. That's all. That is all for today. Thank you guys. See you tomorrow.